Let us start our discussion now for strength of materials. So, new set of problems ang ginather ko para solve ko impronto. So, we are done with the discussion of strength of materials. Pero, pagdating sa bawat problem, I will make you recall all of the idea na napapaloob sa kanya. So, I have here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 problems. Lucky 13 para sa ating lahat. Okay? Sa strength of materials, re-revolve lang naman yan sa stresses. Di ba? Ang stresses ay always equal. Stresses. Yan o, stresses. Always equal yan to the force that is acted upon a certain area. The greater the force, the greater the stress will be. Okay? The greater the force exerted on a small area, the greater the stress will be upon the material na subject to stress. Ganun yun. So for the discussions ng strength of materials, marami tayo dyan stresses, may axial. Okay? Axial, ibig sabihin, the stress is normal to the surface. It is the stress due to axial force or force acting at the centroid of the resisting cross-sectional area. Okay? Whether be it, dalawa lang yan, tensile or compressive. Now, yung shear naman is the stress tangent to the surface. Hindi na sa cross-sectional area, but still, kinukuha mo pa rin yung cross-section area of the shear. Okay? Shearing, ibig sabihin, pinuputol mo. You apply force, you apply stress in order for you to make a shear, nasishira, di ba? Napuputol. Shears, ano yun? Yung gumugupit. Yan yung force na gumugupit sa isang material. Okay? Whether be it a single shear or double shear that will be applied on a single material. Okay? Yan yung nagka-cutting ito. Kung sa shear, may cutting. Dito sa ating axial, meron tayong iniipit at meron tayong binabata. Okay, ganun lang yon. So, going back with the new set of problems, ito yung number 1 for us. The column shown has a cross-sectional area of 13 square meters. So, ito yung column natin. Yung drawing ko. Dahil ako'y engineer, kaya ko mag-drawing. Ayan. Ang ganda ng pagkakadrawing. Ay, balik ko. Sorry naman. Ayan, engineer tayo. Dapat magaling ka mag-drawing. Diba? Sabi nila sana all. Subject to a force application. Now, pag projection ng area niya, what is the projection of the area? The area here projected in here, is at 13 meters squared. Yan yung area natin. Okay? What can be the approximate maximum load if the compressive stress cannot exceed? Ibig sabihin, this is the stress. So, the stress compressive is equal to 9.6 kilopascal. Ngayon, meron tayong given area, ang hinahanap natin yung compressive force. So, that will be equal to force over the area that is given. Cross multiply natin, okay, para makuha natin yung missing na force. So, the force missing there is 9.6 kilonewton per meter squared. You multiply it with the area that is given, 13 meters squared. Very basic. You cancel all the same units, you will arrive with the unit of the force, which is kilonewtons. So, 9.6 multiplied to 13, what will be the result? That will be 124.8 kilonewtons of force, compressive force. Compressive force. Okay? That is for problem number 1. Next problem. A copper column of annular cross-section has an outer diameter of D2 and of 5 meters and is subjected to an axial load of 200 kilonewtons. The allowable compressive stress is 14.4 kPa. The wall thickness T should be most nearly what value? Now, you are given here D2 at 5 meters and is subjected to axial loading. Meron ka ng axial loading dito. So, paano ang solving nito? Pakita muna natin what is an annular section. An annular section here, my friends, ay yung washer. Ayan. Sorry naman. Ay, gawa na lang tayo. Let us draw a circle here. Okay. Let us draw a circle and another circle. I want to draw another circle. Yan. Okay. That is now your circle. The annular section. Okay? Now, you call this part, this one, the one inside, as the inner diameter. The one that is outside is called the outer diameter. And the one na nandito, between them, is the thickness. How will you get the thickness? Okay. Yung DO mo is equal to, tignan nyo, yung thickness na to, dalawa ang magiging thickness mo dyan. Okay? Pag pinag-add mo yung diameter nitong inner sa dalawang thickness mo, that will be equal to DO or outside diameter. So, DI is equal to, DO is equal to DI plus twice of the thickness. Ito yung formula dyan. Okay? Now, how will you get the area of the annular cross-section? The annular cross-section area of the annulus is equal to dalawa. Okay? Ang kinukuha mong area dito, ito. Yan. So, that is equal to pi over 4 d o squared minus di squared. Tandaan nyo to. For annular cross-section. Okay? Now, again, the compressive stress is equal to force over the area that is directed upon. Now, ang kinukuha natin dito ay yung thickness. So, tignan natin. Makukuha natin yung area. Let us reform. SC is equal to force divided by the area, pi over 4 d squared, do squared, minus di squared. But we don't have any di. Pwede nating makuha dito. Yung thickness, going back, thickness is equal to do minus di over 2. So, pwede natin dito makuha yung thickness. Okay? So, reform natin ulit. Excuse me. di is equal to do minus 2t. Kaya lang mahirapan tayo. So, let us say, pwede natin siya isolve mula dito. We have the value for SC, which is 14.4 kPa. Or kilonewton per meter squared. Equal to, the force is given, 200 kilonewton. Pi over 4 multiplied to DO mo. Yung DO mo dyan is, how many? How much? So, 5 meters. 5 meters squared minus di squared. Alamin natin di. Reform natin. Cross-multiply natin silang dalawa. So, pi over 4. Or leave na natin yung pi over 4 sa ilalim. So, ito na lang. 5 meter squared minus di squared equal to 200 kilonewton divided by 14.4 kilonewton per meter squared divided by, multiplied to pi over 4. We cancel all the same units. Cancel na yung kilonewton. So, we can simplify this one. Okay? So, 5 meters square natin. 25 meters squared minus di squared equal to 200 divided by 14.4 multiplied to 4 over pi. Bakit? Kuhanin mo yung reciprocal na ito. Anong sagot dito? Meter squared. Ngayon, pagsamahin natin yung kailangan natin hanapin. So, di squared equal to, lipat natin dito yung di, lipat natin to dito. 25 meters squared minus 200 divided by 14.4 multiplied to pi tuloy. 4 divided by pi meter squared. Then, we get the square root. Ngayon, yung di makukuha na natin. So, this will become 200. No. 25 minus 200 times 4. Tapos, 14.4 shift pi. Square root of the answer is 2.7048. 2.7048 meters. What will be yung DO? So, DO at thickness is equal to DO minus DI over 2. Ayun o. Thickness. Check. So, the thickness now is 5 minus 2.7048 meters divided by 2. The answer will be 5 minus 2.7 divided by 2. The thickness will be 1.148 meters. Very basic. Next one. What is most nearly the stress at surface S? Nasaan yung S? Hindi ito daw. Ito lang naman ang affected dyan. Okay? Yan lang naman. Of the cylindrical object shown, the specific weight of the material is 76.9 kilonewton per cubic meter. Now, dito, meron kang force, di ba? Meron kang force. Yung force na yon, magsasummation ka of all the forces. Summation of the forces vertical. Ngayon, ano ba yung summation of all the forces vertical? Yung summation of all the forces vertical will be yung force na applied there. And syempre, yung weight is actually a force. Diba? It is a mass multiplied to the gravitational acceleration. Diba? Weight. Ayun o, specific weight. Kaya lang, saan natin makukuha to? Okay? You're given then there the dimensions of your cylinder. Okay. So, you have the force applied plus the weight. Kaya lang yung weight saan natin kukunin? Remember, specific weight is equal to the weight divided by volume. The specific weight of the material, ha? Now, how will we get? O, reform natin. Weight ang hinahanap natin. O di, gamma multiplied to volume. Now, the volume of the cylinder is equal to pi over 4 d squared multiplied to the length or the height. Unin natin. Summation of all the force. Yung total force na nandito. Force total is equal to FA. Ano yung applied force? 15 kilonewton. Plus yung volume ng cylinder. Tapos gamma. So, 76.9 kilonewton per cubic meter multiplied to pi over 4. Yung diameter, that is 0.3 meter squared multiplied to height, which is 0.5. Very basic yan. Now, what is the total force? We calculate. So 15 plus 76.9 times pi times 0.3 squared times 0.5. You divide it by 4. So, the total force there is 17. 17.72 kilonewtons. Ang hinahanap natin dito ay the stress at the surface S. Okay. Ano ba yung affected area dito? Yun sa point 3 lang naman. So, the stress there is equal to the total force, kasama yun sa weight, divided by the area of the cross-section. Now, the cross-section affected, yan lang naman, di ba? That your stress is always the force, the ratio on the force upon the directed area, which is ito lang. Oh, total force, 17.72 kilonewton. Divided by AC area niya, pi over 4. D squared, ano yung D? 0.3 meter squared. So, the stress there is 4. Divide by pi times 0.3 squared. The answer is 250.4. Hindi, 250.66 kilo Newton per meter squared or kPa. That is the stress there. So, problem number 3 is also basic. Number 5, number 4. Okay. A 2-meter long aluminum bar with modulus of elasticity 70 GPa. Ngayon, sa steel, ilan ang modulus of elasticity? Ito, E, or malaking E. This is modulus of elasticity. Oh, itong G, modulus of G. Tandaan nyo, G is rigidity. Oh, ngayon, pag steel, tandaan nyo, lagi mas mataas yung E sa G. Okay, balik tayo dito sa strength. Discussion, okay? Okay, meron ako ditong nakalagay. Ayan. Pag E, pag steel, that is 30 times 10 to the 6 PSI, laging gagamitin nyo yun. Sa G, that is between 11.5 to 12. Okay. So, this is, I think, ganyan na yan. I-convert nyo na lang siya kapag SI units. Okay? Sa SI units ata, nasa 83 yung isa. Yung steel, G ng steel, 83, 80 to 83. Yung E naman ng steel, that is in 200. Okay? 200 yan. So, now for steel, ito yung values. Okay? Going back. For steel, that is, hindi ako nagkakamali, 201. Pwedeng 200, 201, 203. Yun, malapit lang yun. Depende sa ibibigay sa inyo. Pero pag gusto niya sure na sure talaga, gamitin niyo ito. 30 times 10 to the 6th PSI. Yan yung steel. Okay? Kapag naman G ng steel, that is 11.5 to 12. Ang parati natin gagamitin dito, 12 times 10 to the 6th PSI. Pag sinabing steel. Now, sabi dito, it is subjected to a tensile stress of 175 MPa. Tensile stress. Okay? Now, anong hinahanap dito? Find the elongation. By formula, elongation, yung paghaba niya is equal to the stress. It is the ratio of the stress over strain. Okay? This is the stress. This is strain. Okay? Anong nanap natin? Elongation. Binigay sa'yo dyan stress, tapos binigay sa'yo elasticity. So, tama ba ako? Going back to the discussion, ito. No? Strain kasi is E. Okay? Now, the relation of the elasticity and rigidity, paano mo kuha yun? Tignan mo ha. Yung elasticity, yung relationship nilang dalawa, that Tignan nyo ito. Tandaan nyo yan. E divided by 2 multiplied to 1 divided by B. Ano yung B? That is the Poisson ratio. Poisson ratio is the ratio of your lateral strain divided by the longitudinal strain. Yan. Okay? So, G is equal to, yan ha, tandaan nyo, G is equal to E divided by 2, 1 plus this one. This is the Poisson ratio. Okay? Going back, yung E, ayan. The strain is equal to the deformation divided by the length. Or pwede rin yung SEE. Stress, modulus of elasticity, and normal strain. Ayan. Ang hinahanap dyan ay yung elongation, normal strain. Okay? Elongation. Sana ba ako? So, the elongation now. Ang elongation is the deformation yan. Deformation is yung iyong nakuha na strain multiplied to the length. Yan, EL. Okay, let us solve. E pala is stress strain. Tama. Stress, elasticity. Okay, elasticity is, yun, strain. Okay, elasticity to. Yan, nalilito kasi ako panay E. Pag nakikita ko. Now, ganito gagawin natin. Hanapin muna natin yung strain niya. Strain is non-unit. Okay? Strain equal to. So, yung stress divided by elongation or elongation tuloy. Divided by your elasticity. So, ang binigay dito is 175 MPa. 175 Newton per millimeter squared. Ang MPa is 1 MPa is equal to 1 Newton per millimeter squared. Tandaan niyo yan, ha? Dito naman, anong di-divide mo? Divide mo dun siya sa elasticity binigay. So, 70 GPa times mo ng 1,000 to. 1,000 GPa, Newton per millimeter squared. Yun ang mahahanap mong strain dyan. Non-unit yan. Cancel to, cancel to. Okay? What will be the strain? So, 175 divide by 70 times 1,000. That is 2.5 times 10 to the negative 3. Non-unit to, ha? Non-unit yan. Yan yung strain mo. Now, how will you get yung elongation? The elongation is the deformation. Pareho lang to. Elongation or deformation. Now, that is, multiply mo yung strain, 2.5 times 10 to the negative 3. Tapos, i-multiply mo yung length na binigay sa'yo dyan. What is the length that is given there? That is 2 meters. Gawin natin in millimeter. So, 2 meter times 1,000 millimeter per meter. Cancel to, cancel to. So, ilang millimeter yan? Multiply mo na lang 2,000. The answer will be 5 millimeter. Very basic. Next one. A 600 millimeter tall thin plate is placed in tension. Tension, hinahatak by a 5,000 kilonewton force. Tension, hinahatak siya. Okay. What is the height in y direction of the plate while the tension is applied? The modulus of elasticity, E is 200 GPa. Diba? Tama naman. So, steel plate yan. And the Poisson ratio, V, is 0.3. Assume the load is distributed uniformly across the plate and yield strength is not exceeded. Ano ba yield strength niya dyan? Okay. Dahil lang isolve yan. Okay. Ang hinahanap mo dyan, ang given sa'yo, ano ba? The given there is the E. Elasticity, 200,000 na lang. Newton per millimeter squared. Now, yung Poisson ratio dyan is 0.3. Tapos, yung force that is applied is 5,000 kilonewton. Now, we are ought to find first the area ng cross-section. The area of the cross-section is equal to 25 mm by 600 mm. So, 25 by 600 mm squared. Anong value niyan? So, 25 times 600. The answer is 15,000. 15,000 millimeter squared. Multiply natin. 1,000 mm squared, 1 meter squared. Ano magiging value niya in meter squared? Divide by 1,000 squared. The answer is 0.015 meter squared. Ayan yung area of cross-section. Anong hinahanap natin dyan? Di ba ang Poisson ratio, ano bang binigay ko? The Poisson ratio is yung lateral strain divide by longitudinal. Ayan. So, this is equal to negative E, lateral, patayo, divide by sigma ba to? O epsilon ata, X. Ayan, that is equal there. Now, for longitudinal, along the horizontal, okay? Horizontal. Yung horizontal, tignan nyo dito yung papunta rito. Ganun naman tensile, ayan punta riyan, horizontal E or strain horizontal is equal to yung stress na binigay sa'yo dyan, divided by E. Okay? Pero may stress ka ba dyan? Tignan mo kung may stress ka dyan, wala kang stress na binigay. Recall mo, di ba ang stress is equal to force over the cross-sectional area? O pwede natin palitan to. Force over area times E. So, ibig sabihin, the strain is also equal to FA divided by E. F divided by AE. F. Ano yung F mo dyan? 5,000 kilonewton divided by A. What is the area? 0.015 meter squared. Tapos yung E mo dyan is, kahit ito, wag mo nang gawing meter to Okay? Okay. Gawin na lang natin ganito. 0. Wag na. 15,000 millimeter squared na lang. 15,000 mm squared. Kasi ito gagawin kong GPA. 200 yan 200,000 Newton per millimeter squared. Tapos to gawin ko Newton times 1 kilonewton, 1,000 newtons. Okay. Makuha na natin yung longitudinal strain. The longitudinal strain now will be 5,000 times 1,000 divided by 15,000 times 200,000. The answer is 1.667 times 10 to the negative 3. Walang unit yan kasi cancel lahat. Cancel lahat yan. Non-unit yan, strain yan. So, the strain longitudinally Eh, yung EY. Yung EY natin, makukuha natin dito sa Poisson ratio. Diba? Diyan, negative. So, EY will be, tignan nyo ito, cross-multiply mo ito. Ayan o, EY is, ito, itong dalawa. So, EX multiplied to Poisson ratio. O, this 0.3 times 1.667 times 10 to the negative 3. Times ko na ito ng 0.3. Okay. That is 5 times 10 to the negative 4. Yan yung sa Y. Or, this is equal simply to meter to. Naka-meter yan ha. Ito, meter din to. May tira ba? 1, 2, 3. Okay, meter. So, this is 0.5 millimeter. Kasi meter to eh. So, multiply ko ito ng 1,000. Oh. 0.5 yung isa. 1. Hindi. 1.667 times 10 to the negative 3. O, di-multiply ko ng 1,000. Magiging ganyan. Okay? Meter. Ngayon, paano natin makukuha yung hinahanap niya dito? Assume the modulus of elasticity. Okay. What is the height in y direction? Okay. Therefore, hanapin mo dyan yung lateral. Okay? Length mo dyan. Na yung length na binigay dyan, that is, may binigay ba yung length? 600 millimeter tall. Okay. Meron kang yung lateral length, that is y, 600, minus yung sa y. Ilan yung makuha ko? 600 millimeter minus 0.5 millimeter. Okay. Hinahanap dyan ay height in y direction. That is 599.5 mm. Mental math na lang yan. Check nyo. That is for problem number 5. Next problem. A 150 mm diameter rivet resists a shear force. Shear, ibig sabihin, kinakat siya. Cutting force of V is equal to 8 kilonewton. So, 8 kilonewton each. Okay? 8 kilonewton. Pag sinabing double shear, dalawa. I-multiply mo ng dalawa yung force. Find the average shear if in the rivet. So, the rivet has a cross-sectional area of 150 millimeters. Okay. So, ang hinahanap dyan is the shear stress. Paano ba ang shear stress dito? SS na lang. SS. Shear stress. Oh, that is equal to V divided by area. Now, hindi naman sinabing double shear. Okay? So, that is force over area. Yung force mo dyan, 8 kilonewtons. 8 kilonewton divided by pi over 4. Tapos, multiply mo ng 150. Wag ng millimeter, gawin ko ng meter to. So, 150 divided by 1,000 meters squared. Yan. So, KPA ang lalabas dyan. 8 divided by pi divided by 4 multiply to 150. 0.5 na lang. 0.15 squared. Okay. The answer is mali. 8 divided by so pi divided by 4 times 0.15 squared. The answer will be 452.71 kPa. Next one. So what is most nearly the maximum allowable load if the factor of safety is 1.5? Tama ba 1.5 yung nasa kopya ko? Factor of safety is 1.5. Tama. And the compressive yield stress or yield is 20,670 kPa. Sir, ano po ba yung factor of safety? The factor of safety is the one that ibig sabihin yan yung times of yung ratio ng yield mo, okay, recorded yield to the allowable stress mo. It is the service factor kung ilang beses mo siyang pwedeng abusuhin, okay? Abusuhin, ilang beses siya ng iyong allowable. Okay? Yung yield, makikita niyo doon sa strength niyo, yan yung point na kung saan malapit na siya sa kanyang limit. Okay? Elastic limit. Now, ibig sabihin, ilang beses allowable mo siya yung loading. Okay? Ilang beses mo siyang pwedeng pahirapan hanggat hindi niya nalalampasan yung kanyang limit. Okay? So, factor of safety, yun na yung pagpapaliwanag dun sa Tagalog. Okay? Ilang beses mo siyang pwedeng pahirapan ng ilang ulit. So, 1.5, okay? 1.5 yung nandyan. This is the allowable. Allowable divide by yung yield. Okay. Ngayon, tignan nyo. This the factor of safety based on the yield. Paano pag ang ginamit mo yung ultimate strength or SUS? The ultimate strength that is recorded and given upon the tables na nandun sa likod ng libro ni Fairs, ni Virgil Moring Fairs. Nandun sa libro yan. So, ang bawat bakal, magkakaiba ng composition, magkakaiba yan ng make. Ibig sabihin, magkakaibang klase ng bakal, magkakaiba sila ng yield, SUS. Yun lang dalawang yun. Yield and SUS. Yield is yield strength and then the ultimate strength. Okay? Yung ginamit dito is the factor of safety based on the yield. Okay? Yield. So, anong hinahanap dito? Maximum allowable load. So, ibig sabihin, 1.5 na beses mo siyang pwedeng i-loading bago siya mag-yield. Okay? So, the allowable is equal to yung sa yield tapos divide mo ng factor of safety. So, allowable, yung yield, that is 2060, 2670 kilonewton per meter squared. The factor of safety is 1.5. Divide muna natin ng 1.5 para makuha natin yung allowable strength. Allowable load, ang hinahanap dito yung F. Okay? F. So, the allowable load is 2670 divided by 1.5. So, 13,780. Allowable strength is 13,780. 13,780 kilonewton per meter squared. Ngayon, nahanapin natin yung force. Saan natin mahanap? Di ba ang stress is equal to force over area? Ang hinahanap natin is force. Force is equal to stress allowable times area. Ang area ng cube is what? Yung element squared. Now, the force is equal to allowable multiplied to the area. So, 13,780 kilonewton per meter squared multiplied to area. So, 125. Divide ko na agad. So, 125 mm divide by 1,000 millimeter per meter. Matitira meter dyan. Square natin yung value. So, the allowable force will become 1370 times 125 divided by 1,000 squared. The answer is 215 8.3 kilonewtons. Very basic. Next one. Yan, mukbangin natin lahat ng problems dito. Hanggang sa magsawa kayo. Meron tayong 2 bar. Mahirap daw to. Actually, hindi nga. Hindi mahirap to. What is most nearly the total elongation of the rod shown? If E is equal to 69 GPa, ibig sabihin they are the same. 69 GPa, close yan. Pagpalagay natin, this is aluminum 2. Okay? Now, anong sinasabi ko? Elongation is deformation, di ba? Oh, ano yung mnemonic ko dyan? Elongation, di ba? Sexy. Elongation. Pauline Luna. Ayaw kay Andrew E. Di ba? Nakangiwi si Pauline Luna. Nakikita, kapag nakita si Andrew E., nakangiwi si Pauline Luna. Ayan. And the force, the length, the area of effect, and then E is the elongation elasticity modulus. Okay? So dito, tandaan nyo, parehas sila ng E, ibig sabihin parehas ng material. If parehas sila ng material, parehas sila ng may experience na what? They have the same stress, which is P over A. Diba P over A is stress multiplied to length divided by E. Ay, mali. Mali pala ako. So, tignan nyo. Excuse me. Going back. Dito, yung total elongation niya. Meron kang elongation at 1. Meron kang elongation at 2. Now, ito, meron kang P, L over AE sa 1, plus P, L over AE sa 2. 2, 2, 2, 2. Anong pareho dyan? Hindi sila pareho ng length. Pero tatandaan nyo, sa bawat material, okay? Kapag iisa yung F dito, the same din yung magiging pull niya dito. The force is additive. Okay? The force is additive. Now, makita nyo dyan, okay? Isa-isay natin, total elongation ang hinahanap. Total elongation, mamaya ako na-discuss pala pag parehong material. Parehong material, the same lang yung makukuha nilang strength. Yan. Okay, yun. So, P, A, yung P, parehas lang, which is F. Yung E, parehas lang. So, pwede ko i-factor out. P over E. Multiplied to L divided by A, 1, 1, plus L, 2, divided by A, 2. Pwede ko na simplify. So, P, ano yung P dyan? That is 27 kilonewton. Divide by E. I think that is 69 GPa. 69,000 na lang. Newton per millimeter squared. Ito gawin ko na tong millimeter tuloy. Newtons. So, 27,000 newtons. Multiplied to the length. Dapat yan naka-millimeter. Ano ba yung length natin dyan? The length is, length 1, 2.5, that is 2,500 millimeter. Convert nyo na kagad kung pwede. Tapos, the area of effect. Diameter nung una is 300 millimeter. So, bilog yan. Pi over 4. 300 millimeter square natin. Plus, yung pangalawa, 1.75, 1,750. 1,750 millimeter. Divide by pi over 4 times 150 mm. Square the value. So, we cancel all the same units. Yung Newton. Yung millimeter dito, mabawasan, millimeter dito. matitira lang ay what? Aakit kasi to eh. Ang matitira, 1 millimeter nandito. So, 1 millimeter. Yan. So, what will be the deflection or the elongation? Sa isa natin, 27,000 divide by 69,000 multiply to 25. Tapos, pi over 4 times 300 squared plus 1,750 divide by pi divide by 4 and then 150 squared. Sa pindutan, makuha natin yung value of elongation which is 0.053 millimeter. For that force ng pagbatak pababa. Next one. What is most nearly the total elongation? Yan na naman. Balik na naman tayo. Ganun lang. O ngayon, hindi na magkapareho yung E. Okay? So, anong gagawin mo? Ilista mo ulit. The total elongation. Elongation sa 1 plus elongation sa 2 equal to P 1 L 1 over A 1 E 1. Oh, tandaan nyo, E1 is not equal to E2. Pero yung force niya, equal pa rin yan. P1 is equal to P2. Yan. Plus P2L2 over A2 E2. Factor out na natin to. Same lang naman sila. So, elongation. P. Yan na. P1 and P2 equal lang naman yan. Oh, L1, A1, E1 plus L2, A2, E2. Okay. Total elongation is yung P, 175 kilonewtons. O, di 175,000 na lang yan. Newtons. Multiplied to L1. What is L1? Yung length 1 is 0.12 meters. O, di 0.12 times ko na agad ng 1,000 para maging millimeter. Yan na. Okay na yan. Area 1, pi over 4. Yung diameter niya, anong binigay dyan? Ay, diameter pala yun. 0.5 pala ito. Mali. Pwede na to. Yung length is 0.5. 0.5 times 1,000 millimeter. Dito, ang binigay is 0.12 meter. So, that is 120 millimeter squared natin. Times E. Ano ba yung E na binigay nung una? 70 GPa o 70,000 Newton per millimeter squared. Plus, okay? Yung binigay na pangalawa, 1 meter. Di 1,000 millimeter. 1 times 1,000 yan eh. Tapos pi over 4, 0.06. Bali, 60 millimeter squared times E. That is 100 GPa. 100,000 Newton per millimeter. Ang lalabas ulit dyan ay mm. Nag-iisa na lang. Okay? What will be the answer? Ang pindutan. So, 175 So, 0.5 times 1,000. 500 na yan. Tapos, pi over 4 times 120 square the value times 700,000. 70,000 lang. Plus 1,000 pi over 4 multiplied to 60 squared multiplied to 100,000. The answer is 0.729 millimeter. That is the total elongation. Ganyan lang mga problem dyan. So, for the last 4 problems, a rigid weightless bar is suspended horizontally. By cables 1 and 2 as shown. The cross-sectional areas of the cables are given the figure. The modulus of elasticity E is the same for both cables. If a concentrated load of F is equal to 1,500 kilonewtons is applied between points A and B. So, nandito sa gitna. Ayun, A and B. And most nearly the distance X. Nandito siya, hindi pala gitna. Nandito yung F. Ayun, nandito. What is most nearly the distance X for the bar to remain horizontal? Alamin natin, okay? Magsasummation of moments tayo dito. Ay, meron bang binigay dito? The modulus of elasticity is the same for both cables. So, E1 is equal to E2. Yan, yung assumption natin. Meron tayo ditong force 1, meron tayo ditong force 2. Yung mga bumabatak dyan. Okay? Now, yung cross-sectional area given dito, A1, A2, and F. Na anong gagawin natin dito? Okay, number 1. Ang gagawin ko dito, A. Mag-summations of moments ako. At what? At what? Pwedeng A, pwedeng B. Pero I'd do it at B. So, 0. Positive yung clockwise or counterclockwise. So, bahala dyan. So, ito muna. Positive natin yung pag ganun. So, ano yung mga magpapass through dyan? Yung A. Itong sa A, F1 multiplied to gaano kalayo? 3,000 mm equal to itong B, pabaliktad. So, dito sa kabila minus yan Pag nakuha mo 0, di F1 times yung distance dito 3,000 A to B minus, pabalik na ito, F multiplied to X. F multiplied to X, hindi natin alam. Meron tayong isa equation dyan. Okay? Ayan. B, gawa tayo. What if mag-summation of forces ako at Y equal to 0? Lahat ng pataas, ilan ang pababa? So, pataas ito, positive. Okay? Positive yan. Pagpataas. So, makakabuo ko dito, F1 plus F2 is equal to F. Yan lang kadali yun. Where F is equal to 1,5. Ayan, pwede natin palitan to. Translate ko na to. So, X is equal to 1,5 to F1 times 3,000 divided by 1,5. Yun. Equation na nabuo ko dun sa taas. So, F1, F2 is equal to 1,500. Meron pa ba iba tayo dyan? Meron pa ba tayo iba nakikita dyan? Wala pa. So, tuloy lang tayo ng solving. Ito yung equation na pangalawa. So, letter C, what if? Ibig ko sabihin dito, yung deformation na mangyayari dito is the same the deformation na mangyayari dito. Bakit? Pareho lang po sila ng elasticity. Okay? Ibig sabihin, yung deformation at 1 will be equal to the deformation of 2. Kasi pareho sila ng E. Okay? Mm. Deformation ng 1 is equal to deformation ng 2. Meron tayong F1, L1, A1, E1 equal to F2, L2, A2, E2. Diba ang sabi dito, the same lang naman yung kanilang what? E. O di cancelable yung E. Cancel na yung E. Ibig sabihin, pwede kong makuha si F2 or F1. Okay, cross-multiply ko na lang itong dalawa. So, F1 is equal to F2, L2, A1 over L1, A2. Meron na ba akong F2 dito? Meron na ba akong F1? May L2, may L1 ako. L2 and L1, meron ka dyan. Ito. So, first, F1, F2. So, meron kang F2, L2. That is 1,000 millimeter. A1. Binigay sa'yo dyan. 1,300. Yung L1, that is 600 millimeter. Tapos A2, that is, ano ba A2? A2 is 650. 650 mm squared. Ay, tama naman. 650, hindi yan 850. Makuha na natin yung F1 to F2, yung ratio ng dalawa. F2, kunin ko muna. 1,000 times 1,3 divide by 600 times 650. The answer is 10 over 3. So, F1, yung ratio nila is 10 over 3 ni F2. Yan yun. So, pwede ko na siyang what? Pwede ko na siyang i-substitute dito. Kahit saan dyan. Dito muna, F1, F2. So, dito, pwede ko siya i-substitute. So, F1 is equal to 1,5 minus F2. Yung F2 ko is 3 over 10 ng F1. 3 over 10 F1. Pagsamahin ko, yung parehas, F1. So, F1 minus, plus 3 over 10 F1 equal to 1,500. So, F1 is equal to 1,500 divided by 1 plus 3 over 10. What will be the answer for F1? F1 is 1,500 divided by 1 plus 3 over 10. So, F1 is 1153.85 kilonewton. Tama ba nakalagay dyan? Ayan, kilonewton. How about F2? Di minusan ko na lang to ng 1,500. The answer is 346.15 kilonewton. Meron na akong F1 and F2. Mahanap ko na ngayon si X. So, X is equal to 1,500 times F1. Hindi, F1, 3,000 pala yun. Sorry naman. 3,000. Tapos, ay F1 is 1153.85. kilonewton divide by 1.5 kilonewton. Ito mm to eh. Multiplied lang by 2. So, x will be 3,000 times 1153.85 tapos 1.5. Para minultiply ko lang ng 2. So, the answer is 2307.7. Yan dapat yung layo niya para ma-maintain mo yung deflection. Same deflection. Okay? That is for problem. Last of the 4 problems. Next one. A prismatic bar at 10 degrees Celsius is constrained in a rigid concrete wall. Andun daw siya. Ay yung prismatic bar nakaipit dun sa dalawang concrete wall. At both ends, the bar is 1,000 mm long. O, haba niya 1,000 mm. And has a cross-sectional area of 2,600 mm squared. What is most nearly the axial force in the bar if the temperature is raised to 40 degrees Celsius? That is the change in temperature. Ay, hindi pala. Yan yung augment ng inyong temperature. From T1, tapos ito yung T2. Okay. Ano bang formula natin for thermal stress? For thermal stress, ay, na-stress tuloy ako. For thermal stress, tandaan nyo. Yun, no? For thermal stress, that is equal to alat. Alat. Ay, delta T. Alat. Where A is the coefficient of thermal expansion. Okay? Alat. L is the length of the bar and the delta T is T O, hindi, T final, T1, T final minus T initial. Yan, alat. Hindi yan thermal stress ha, hindi pala thermal stress to. This is thermal elongation. Yan. Kapag stress is thermal. Hindi tensile ha. ST is equal to is ata to. Okay. Dito yan, strength. For the strength, andito yan. Yan. Thermal expansion, ito yun. Sa stress, nilagay ko dito yun. Para may reference tayo. Ako nawala. Ayun, E80. Alala ko na. Stress is SE80. E80. Yan, E. Okay? Ganyan yan, E80. Axial force in the bar. Yan ang hinahanap. So, ano ba yung naging deformation dyan? Okay? Thermal deformation. Consider mo muna. The thermal deformation or elongation A. 9.4 kapag prismatic bar. Hindi ata steel to. Iba yung sa steel eh. 9.4 times 10 to the negative 6. Okay? Per degree Celsius yan. Multiplied to L na 1,000 mm, 1,000 mm, times 40 minus 10. Ito per Celsius degree to. Ito, degree Celsius. O di cancel to. Cancel to. So, we have 9.4 times 10 to the negative 6 power. Let's multiply it with 1,000 times 30. The answer is 0.282 millimeter. Anong hinahanap? The most nearly axial force in the bar. Ano yung magiging axial force in the bar? Paano makukuha yung axial force? Simple lang, 'di ba pag mayroon kang deformation, mayroon kang pulin luna, ayaw kay Andrew E. Mm. Yun. So PA, itong kinukuha natin, PL over AE. So ang kinukuha natin is P, meron tayong thermal elongation, deformation, the same, A times E divided by the length. Now, P is equal to 0.282 millimeter multiplied to A. The area there is 2,600 millimeter squared. And then E. Ang binigay dyan na E is 200 GPa. Steel siya. So, therefore, steel din to. Yung value na to for steel. So, 200,000 Newton per millimeter squared. Divided by L. Ano yung L mo dyan? 1,000 millimeter. So, cancel yung millimeter squared. Ang natira is newtons. So, times 2,600 times 200,000 divide by 1,000. In newtons to O, divide mo ulit ng 1,000 para maging kilonewtons. That is 146.64 kilonewtons. Or 146,640 newtons. That is for that problem. Last two problems. A 3 millimeter diameter bar experiences torque at 280 Newton millimeter or meter. What is most nearly the maximum shear stress in the bar? Matandaan nyo ito. The torque is equal to force times radius. Ayan yun. The torque is equal to force times radius. Okay? Or, that is equal to force times d over 2. Or, para makuha mo naman yung force, tandaan nyo, the force there is equal to twice of the torque divided by the diameter. Yan lang yung mga formula dyan. Yan. Now, what is the shear stress? For the shear stress or SS, that is given by this formula. So, that is yung torque multiplied to the radius times J. Or the polar moment. Polar moment of inertia. Ano yung J? Polar moment of inertia. For circular, J is pi over 4. Pi over 32 ata. 32 d to the fourth. Ayan. Pi over 32 d to the fourth. 2. 2 times 2 times 2, 16. Ay, tama. Tama ako. So, that is the solution. Hanapin mo muna. Okay. Shear stress. Pwede rin to. SS is equal to 16T over pi d cube. Para mahanap mo yung stress. Yan yung formula dyan. Sir, saan nagmula yan? Tignan mo dito. Dito nagmula yan. Saan ba yun? Wala sa shafting sa ata yan. Okay. Hanapin natin. Yan, sa ME notes. Doon ako dito. Ayan. For solid circular, yung J dyan. Ayan, dito. Ayan, TC over J. Ito. Polar moment of inertia is J. Tama naman. Pi over 32. Ito yung nakikita nyo. Tama ako dyan. Tapos yung stress niya, Ayan, 16t over pi d cube. Kabisado ko pa rin talaga. Okay. Araw-araw ka lang mag-solve, mga kabisado mo sila. Okay, polar moment. Ito yun, no? Polar moment of inertia. Yan. So, meron ka niyan. How about? Mhm, 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 mhm. Solving natin sa kanya. Paano natin solve? Binigay na sa yung torque. Meron ka bang D? Diameter, yes. What most nearly the maximum shear? O the maximum shear is equal to 16 torque. Ano yung torque na binigay yan? 280 Newton meter. Divided by pi d cube. Diameter, ayun, 3m. So, kPa yan lalabas dyan. 16 times 280 divide by 27. 3 times 3, 9 times 3, 27. Shift pi. The answer is 52.82. 52.82 newtons. Very basic. Next one. The last one. So, what most nearly the angle of twist? For angle of twist, yan sinasabi ko sa inyo, di ba? Pag nakakita ng sexy, di ba ako pag nakakita ako ng sexy, lagi ako nakasombrero para hindi ako malatan nakatingin sa kanya. Tulo laway ni Jimbo Guapings. Yan, no? TL over JG. Where T is the torque that is given there and the length of the bar or the length of the shafting. J is the polar moment of inertia and G is the modulus of rigidity in shear. Now, pwede pa natin to expand. Okay? T, L, over. Yung J natin is pi over 32 D to the fourth multiplied to G. Simplify natin yan. Oh. So, T, L, 32. Inakyat ko yung 32. Pi, D to the fourth, G. Ayan ang ginagawa ko pag nagbo-board exam ako. Kaya hinahanap natin, given dito yung length of the bar, the diameter of the bar, the torque given na, very basic, and rigidity is 26 GPa. Very basic. Hindi na natin kailangan mas advanced pa yung mga sinolve ko previously. Dito, napaka-basic lang. So, you should watch yung shaftings ko and then strength of materials. Marami akong tinurong technique doon. Should follow. You search doon sa aking playlist. Meron ako doon. Shaftings and strength of materials review. Andun lahat sila. Yung pinaiikot-ikot ko lang yung problem nito pag may given power, tapos solve ko yung angle of twist, solve ko yung torque, solve ko yung diameter of the shaft. Umiikot lang yun doon. So, let us solve 32. Ang laging unit nito is in radians. Non-unit, radians yan. Ngayon, kung gusto mong gawing tawag dito in degrees, just multiply it with 360 divided by 2 pi or 180 divided by pi. Okay, 32 times the torque given there, that is 11 kilonewton meter. Gawin ko na lang, pwede na, 11 kilonewton meter. 11 times 1,000 newton times 1,000 millimeter. Para lahat naka-millimeter. Okay, times the length na binigay dyan, 17 meters, so 17 times 1,000 millimeter. Divide by pi, d to the fourth, that is 0.8 ata to. Hindi ako nagkakamali. Yun D. Ba hindi dito? 0.6 or 0.8? Makita. Teka nga, 0.6 to the fourth. 0.8 to the fourth. Parang hindi ah. 0.8 ata to. Sige, 0.8 na lang yan. Okay, 0.8 times ko ng 1,000 mm to the fourth. Tapos yung G, that is 26 GPa. 26. 260,000 Newton per millimeter squared. So, lahat yan cancel. So, Newton, yung millimeter, millimeter, millimeter to the fourth, millimeter squared Newton. Ang matitira is in radian na lang. So, the answer will be 32 times 1, 2, 3, tatlo yung 1,000. Tapos dalawang 1,000 dito sa baba, isang 1,000. Tatlong 1,000 o di 1,000 cube nasa taas times 11 times 17. Pinaikli ko na lang yung pindutan. So, pi times 0.8 times 1,000 to the fourth times 260,000. The answer will be, okay. So, naka-radian pa to. Multiply ko na lang para hindi tayo mahirapan. Naka-radian pa yan, di ba? Multiply ko na lang ng 360 divided by 2 pi times 360 degrees divided by 2 pi rad. Alagay kasi dito, radian na yan lalabas eh. Times 360 divided by 2 pi. Okay. Ilan degrees? The answer is 0.001024 degrees. That is for the final problem for strength of materials. Again, for more comprehensive and very difficult problems na pinadali ko for solving ng shots and strength of materials, just follow and search them on the YouTube. Okay, YouTube page ko. Andun lang yan. Pinasimple ko lang yung solving. Okay, that will be all. Have a nice day. Bye-bye.